Have you ever wondered why matter has mass? I mean, really, why? Not just what the textbooks say, that protons and neutrons have a certain weight, but what actually makes them heavy in the first place. Most scientific models, like the Standard Model of particle physics, tell us mass comes from the Higgs field, but they stop short of explaining how the field actually gives particles that mass. It's like saying gravity makes things fall without explaining what gravity really is. That's where my work comes in. I'm Tom Millar, and I've spent years developing something called the Millar Cosmological Model, along with the Higgs Barbell theory. And what I've found is surprisingly simple, something I call stuck points. Let me explain. Every proton and neutron in the universe isn't just floating around with mass magically built in. What I propose is that these particles actually anchor themselves to the fabric of space through tension. That tension is what gives them mass. One anchor point or stuck point for each proton or neutron. So, let's put this to the test with real numbers. First, take hydrogen 1, the simplest atom. It has just one proton. My model predicts one stuck point equals the mass of a proton, which is about 938 million electron volts, or 1.67 times 10 to the minus 27 kilograms. That's exactly what scientists have measured. That's 1 for 1. Perfect agreement. Now, let's go a little bigger. Take helium-4. It has 2 protons and 2 neutrons. That's 4 stuck points. Multiply that by the same unit of tension, and my model predicts a mass of about 6.64 times 10 to the minus 27 kilograms. Check the official scientific data, same result. Another perfect match. Let's push it even further. Iron 56, the element at the heart of stars, has 56 protons and neutrons. That's 56 stuck points. My model predicts about 9.28 times 10 to the minus 26 kilograms. Measured value? 9.30 times 10 to the minus 26 kilograms. That's less than 0.25% difference. And how about uranium-238? The heavyweight of the periodic table? 238 stuck points. My model predicts 3.95 times 10 to the minus 25 kilograms, which again matches experimental data within a fraction of a percent. Let that sink in. From the smallest atom in the universe all the way to uranium, the heaviest naturally occurring element, this simple rule holds true. No other model does this. Not the Standard Model, not string theory, not supersymmetry. None of them predict mass by counting structural anchors in space the way the Millar Cosmological Model does. They describe where mass comes from in abstract terms, but they don't give you a working equation that fits all the elements this cleanly. This isn't a lucky guess. This is a structural truth waiting to be recognized, and it goes beyond just mass. This model ties into gravity, dark matter, even the formation of the universe itself. Because if mass comes from tension in the fabric of space, then space itself is not empty. It's alive with structure, and we can measure it. So here's my invitation to you. Whether you're a scientist, a student, or just someone who's curious about how the universe really works, I invite you to take a closer look. You'll find that this model isn't science fiction. It's science uncovered, grounded in real numbers, real physics, and real experimental validation. This is the Millar Cosmological Model, and this is just the beginning.